All right, so we're back, and now we're going to look at some examples here. Let's move this over here and this over here. All right, so we have our geometric object class. Now, we've talked about this before in terms of back when we talked about inheritance in a couple weeks ago, and we talked about where this example of the geometric object, and we had different types of objects that we created from that, like circles and rectangles and stuff. Right, but now we're saying the geometric object class, it does not make sense for us to have anything that's just a general geometric object. That when you say geometric object, when you say shape, right, what you mean by that is you mean something, like you mean something real, like a circle or a rectangle or some other shape. Like, what does it mean for something to be a shape? Right, there are certain things that they all have in common. In our case, we're saying their color, their whether or not they're filled or not, the date created. Like, these are things that they will have in common, right? But for each individual type of shape, some things are very different. So we have the standard, get and set methods, right? The getters and the setters, the is filled and set filled, the date created, which we can't change that. That's why we only have the get date created. We don't have a set date created. Okay, and we have a toString method that tells us something to return when the object is used as part of like a print line statement or something like that. Okay, all right. But notice that there's a couple of abstract methods here, like get area, get parameter, right, that says all of our shapes are going to have an area. All of our shapes are going to have a parameter. How those are defined are different based on the type of shape. Okay, so if we look at our circle, just like before, our circle extends its parent class. So a circle has a radius. That's how a circle is defined. A circle is defined as all sets of points that are a certain distance from a central point. Right? That's what the definition of a circle is. So we can have a circle that has a radius of, in this case, what would the radius be if a circle is declared with no parameter? What's the radius? Undefined? What is the radius in this situation? Zero, that's right, yeah. Well, technically, Emre, you are right. Emre is you're more technically correct, which, as a friend of mine, one of my graduate students told me in a discussion yesterday, it's like the best kind of correct is the technically correct, right? But yes, 0.0 because it's a double variable. Okay. But otherwise, we have a constructor that takes the radius value. Right? We can get radius, we can set radius. We're not worried too much about like if radius is greater than 0. In this case, that would be something we would include if this were something we were doing for a true customer. That would go back to the exception handling, but the focus of this is things like this override, get area, this override, get parameter. Right. What we might even include is something like this, where we might say public double get circumference. And what we return is we can just return get parameter. Right. Okay. But notice that a couple of things I want you guys to see. One is the override notation here. This override command, the compiler directive, tells the compiler this method is something I'm overriding from the class above me, from the parent class. Remember why we did this. Why we did this is because if we spelled it wrong, the compiler will tell us there's no method in your parent class named that. Right, and so that's a way for us to make sure that we are overriding the correct method. Okay. Now, in this particular situation, had we spelled it wrong, we'll see what would happen in just a moment. Right. But now I'm going to save this. I'm going to compile this. This should be no problems. Right. I'm going to compile this. And, right. Now, what happens here? These chairs. All right. What happens here? This overrides and implements the abstract method from the parent class. Okay. If I were to have spelled this wrong, right, and if I were to try to compile this, I get a couple of errors, right? Okay. Circle is not abstract, but there's an abstract method called getArea with a capital A. Right. So if we look back at geometric object, there's this abstract method that I didn't override. Also, right, this saying, so it's kind of a double whammy, right? It's a double error, but for the same reason. The same one wrong character caused two compiler errors. One saying that you didn't override a method that's abstract, and two, you didn't, this method that you're saying you overrode doesn't actually exist, right? So if we did not include that compiler directive, we would still get the error about not overriding a method in the parent class, but now we lose the one that's saying, but you didn't override. This one isn't something overridden. Okay, so it's a special way that we can kind of check ourselves to make sure that we are actually overriding the method that we're looking for. Okay. So if, for example, we had said override to our new method, because we said that, we would get a compiler error saying, hey, this method get circumference, that doesn't exist in the parent. I don't know what you're trying to do, but that doesn't exist in the parent. Okay. Remove that. All right. All right. In the same way, our rectangle. A rectangle is defined as, all right, width, height, where the rectangle, if we don't pass any parameters, our width and height is just 0 and 0. Right. Same though, you know, get and set stuff, and we have the get area and get parameter methods here. Okay. Now, what if we wanted to create a new? Oh wait, there's a test. Let me run this test stuff here. Okay. So here, notice we're creating a geometric object variable that contains a circle. Then we're creating a geometric object variable that contains a rectangle. We also define this equal area method that takes two geometric objects. Now notice I don't have to cast object 1 to be a circle or a rectangle specifically to get access to its getArea method. Why? Let's take a look. Why? Because that method exists in the parent class. And it will still use the same getArea method of the child class in this particular case, right? It's going to use the getArea method of the circle because that's the type of object that it is. That's where that method is defined. So let's take a look at this specifically. Let's compile this. Let's see how this works in practice. Okay. We created an object 1 that's a circle, created an object 2 that's a rectangle. Do the two objects have the same area? Well, what's the area of object 1? Object 1's area is the circle of radius 5. What is that? 75, it's a bit small. It's a little bit bigger than 75. Yeah, it's 25 times pi, whatever that is. Yeah, I think that's how we defined it, right? Yeah. Radius times pi. Yep. Okay. Let's see. All right. Object 2, getArea. All right, what's the area of object 2? It's not 25 times pi, so I can guarantee you that they are not going to have the same area. Nope. So then when we go to display object 1, right, the area for object 1 is, step in, is 78.5, so that's that 25 times pi, right? Again, notice we are calling the getArea method using the object reference variable, the geometric object reference variable. We don't have to call this, we don't have to cast that to a circle. We don't have to cast that to a rectangle. Okay. All right, so let's create a new geometric object. Okay. Let's kind of use, let's create a square. So I'm just going to copy this over for our new one here. Okay. A square is what? It's a side, right? It just has a side, right? It has a side length, right? Okay. So do I need to create all this? Do I need to create all these methods and stuff? Am I going to have to go through all this, get side, get width, get height, get side, get area, get perimeter? Do I need to do all that? What do you think? Or is there an easier way I could do this? Do it boilerplate as a feature. What do you mean by that, Metahan? I think you may be using some fancy language, but thinking the same thing I am. Yeah, we can add automatically, but what I mean by that is, think about this. What is a square? And how is it related to something that we already have? Yeah, what if instead of extending geometric object, what if I extend rectangle? Well, and instead of having a variable called side, what if right? And get side, instead of returning side, I just return my parent get width. Right? Now how do we, what about setting side? What do we do there? We can set the width to be side. Is that enough though? Or do we also need to set the height? I probably need to set the height also, right? And guess what? All the other stuff's already created for us, right? We have a get area method. We have a get perimeter method. It's all already set for us, right? We don't need to change the get area method. It's the same. It's width times height. It's just that both are the same here. We don't have to change the get perimeter method. Right? It all exists. So let's see. Let's test this out. Let's, in addition to this, let's create a geometric object 3. Or actually, you know what I'm going to do? I'm going to do something different. I'm going to show you. Okay, so we're going to create a new square and we're going to assign it to geometric object 1. So it was a circle, now it's a square. Okay. Let me do this. Let me do 6 times 6, 36. And then let me display that square. Yep. Okay. All right, so this should work now. So let's just go down to this here. Okay, so before this line, geometric object 1 points to a circle. But once we do this, we're going to create a square. So now it's a different object. It's now a square. All right. Do the two objects have the same area now? Geometric object 1, a square of side length 6. A rectangle, right, a rectangle with width and height 12 and 3. Do they have the same area? What do you think? Does a square of side length 6 and a rectangle width 12, height 3 have the same area? Yeah, they should. True. Now, you may remember from last semester, we talked a bit about using the double equals for two double values, that's not always a good idea. In fact, it's frequently not a good idea. We'll talk in a minute about how we can make sure that our get area, that our equal area is correctly understood here. Okay. And then finally, we display the geometric object. So it's going to call the toString method, but there's no toString method. Oh, sorry, it displays the get area and get perimeter. Sorry, that's not. Right. So the area is 36. The perimeter is 24, which is 6 times 4. Yep. So there you go. Okay. Now, we talked last semester about why this may not be the best way to compare two double values. The reason for that is because 0, so let's say 36.0000001 does not equal 35.99999. For example. But we might want to say, yeah, those may not be exactly the same, but they're close enough, right? They are close enough, right? So what we may want to consider doing instead of this is we define this epsilon value, right? And then we say, okay, the absolute value of the difference of these two right, is less than our epsilon value. So epsilon's a math term for the difference in, and we're saying we want to make it small enough, right? So now if the get area of one minus the get area of two of the other, and the reason why we don't just say, the reason why we need the absolute value part is if this one is slightly larger than this one. So for example, if this happened, if it was 36.001, 35.9999, right, then this would be a positive value. If they were put in the other way around, the 35.9 here, the 36.0 here, then this would be a negative value, but it's practically the same. So then we put the absolute value on that to make it a positive, and then we say, is it less than the absolute? Is it less than that small value? So is it basically within 10 to the minus 6 of each other? And scientifically, that's practically equal. Okay, so this might be a better way to do the equal area method. Okay. All right, we've got time for another quick possible example here. Okay, so here's another thing where we might say, okay, where we might have an abstract class called person. Make sure this compiles good. Yep. We have an abstract class called person, and all people have certain characteristics in common, like a name. Okay. Then we have a get name and a set name method and all that. Then a teacher extends a person. So what we're saying is a teacher is a type of person. I know. You're like, are you sure? Are you? I don't know. Some teachers, yeah. Some teachers, maybe they are people, but there's others. We're concerned they're robots or aliens or something like that. We're not sure, right? But we all are. All of us are people. All right. So maybe a teacher might have an ID. Okay, like I have a employee ID. Okay. A student also extends a person. That one's much more believable, I think, for you guys. Right? Okay. Now, in addition to having an ID, a student has, we're going to say they have an advisor. So now the way that I've set this up is that the student and the teacher both have constructors of no parameter being passed. Just their ID is passed, their ID and their name is passed. Okay. Now, a couple of questions. Let me go back to the person one here first. So notice that one of the things I did is with a no arg constructor for person, I call the single argument constructor with anonymous, because that person is, we'll say they have no name, they're anonymous. Okay. If I go down to the student one, no arg would call the super, right? What we're not seeing, what's hidden there is that, right? No problem. There's no compiler error there because there is a no argument constructor for person. That's fine. And same thing here, super with no argument. Now, up above, what I did was I said I called the no argument constructor. So why not here, like I did with person, where for the no argument constructor I called the single argument constructor? Why here don't I just say, well, if I'm going to call the super with name, why can't I just then also, that code is the same as that code, why don't I just do this? Where I call the parent constructor with their name, and I call the local constructor with their ID, since that's the same code, everybody's happy. Why didn't I do that? What do you think? Let's see. So anytime we call a constructor as part of a constructor, it must be the first line that appears. So because we already called a constructor here, we cannot call another one here. Okay. So that's important to know, okay? And that also makes for good quiz and exam questions, just so you know. All right. All right. So let's test this out. Let's see here. Let's do a main method. And let's create a couple of students and a couple of teachers. One with no name. going to use the last 3 names of students that commented on here. He was the last commenter. Han was the one before that, and Metopsueda. And I think my computer is going to give me issues with that U with the dots, so I'm going to replace that. Sorry, Metopsueda. I don't know which name you want to go by, but all right. So we've created a few of those. All right. Now let's create a few teachers. Well, we already have a Meli as a student. There's a lot of M's. Meli, Marat. Let's say Umit Hoja. And let's make one with no name also. Now let's do a few things. Let's set S1 set advisor to be T1. And let's do the same thing with S2 and S3 to be T2 and T3. All right. And let's do one other thing. Let's make a toString method in the person class. Now let's just say their name is there. Oh. What? Oh, string, because he has to have an ID. Error. All right, let's make your ID 1. Or no, so let's make the same as the number. And then teacher is actually the same thing. Advisor for S1 is S1 dot get. We'll do the same thing for 2 and 3. And 4. And 4. Okay. You're going to see why I didn't just say T1 here and T2 here and T3 here. Okay, you're going to see why in just a moment. So this should be okay now. Okay, good. All right. So now let's see what happens as we step through this thing. So we're creating all of our student objects, right? So now we're setting our advisors. So now the advisor for S1, well, what's the name of S1? Or sorry, what's this going to say? Advisor for who is who? Anonymous, advisor for anonymous is Joseph. Emre, let's see if you're right. All right, good. Yep. Let me make that a little bit bigger down there if I can. Okay, good. Next one. Advisor for who is who? The advisor for Meli is Umit. Yeah. Yep. All right. Next. Maybe somebody other than Emre. Now let's see. S3. Who's S3? Advisor for Metahan is S3's get advisor. What did we say? That if the teacher has nothing, all right, we call the super constructor with no parameter. The super constructor with no parameter gives us anonymous, right? So the advisor for Metahan is anonymous. Metahan, you have an anonymous advisor. Okay. And then finally, the advisor for S4 for Metap Sueda is, well, we never set her advisor. Never set that advisor, so let's see. Is no. All right. So what happens there? There's nothing that's pointing there, right? The get advisor here, there is no advisor. Just ahead of your time, yeah. All right, so there isn't an advisor for Metap yet. So that's how we can see how we could do these things. And this is how, notice also, we cannot create, not that. We cannot create just a person object. So if I were to try to say person P equals new person with a name, I will get a compiler error, right? Because person is abstract. I cannot instantiate. I cannot create an object of that type. But what I could do is I could do this. All right. I can compile this. Because what we've done here now is the reference variable P that must point to a person object is also now pointing to this student here. Okay. So it's pointing to the student object that S4 points at, right? The same thing. But a couple of things I can't do here. Even though this is a student object, I can't say, let me do it this way. Can't do this. Because when I try to compile this, it's going to say, oh, this whole get advisor method doesn't exist for the person class. That doesn't make sense. Right? Now what I could do is I could say, well, but asked P to a student and then use its get advisor method. Right. And then when I run this, there it is. Works just fine. Okay. But as a final thing before I let you go, all right, if I were to, instead of doing S4, if I were to say, okay, T3, if I compile this, now T3, teacher is not a student, doesn't have a get advisor method. Is this going to cause a problem? Is this going to cause a compiler error? No compiler error. Right? Because the compiler doesn't know that this P is not a teacher. Is not a student. It knows that this P is a person. It knows that student is a child of the person class. It knows that the student class has a get advisor method. Everything's fine as far as the compiler is concerned. The compiler is like, yeah. If you cast my person object to a student, it should be able to use a get advisor method. No problem. I've got no issues with that. But then when we try to run it, let's get down there. When we try to run it, when we try to execute this line of code, I'm going to get an exception, right? Because a teacher cannot be cast to a student. Okay? Teacher and student are separate classes. They're both children of the same parent class, but a teacher cannot be cast to a student. Okay? All right. Hopefully you guys learned something today. Hopefully you understood what we talked about, and we will come back tomorrow and talk about interfaces. Are there any questions or comments before we end for today? Okay. All right. So I encourage you, look at the example here, the lecture 12. Try to play around with it. Try to see what you can do with it. Run some things, and then yeah, just try to see what you can do with the abstract class and things like that. Okay. All right. Have a good afternoon, good evening, and I will see you guys tomorrow afternoon at 1:30.